Okay, I'm back, and in the previous segment, we have now shown that when the sun's rays are coming in perpendicular to the ground, then the light is going to be more concentrated and it's going to be hotter. And then when the sun's rays are coming in at an angle, the light is more spread out, so it's not going to be as hot. And then we found out that because the Earth is circular, it's curved, because it's curved, that means that at the equator, the sunlight's going to be coming in more perpendicular, so it's going to be hotter. And then at the North Pole, it's coming in more at an angle, so it's going to be colder. Now what we want to do is to include the effect that the Earth is tilted. So the Earth's spin axis is not straight up and down like this, but it's actually tilted like that. So it's tilted at a 23-degree angle. And one of the things that we're going to learn in the next lesson is that if you have an object that's spinning, then the spin axis always points in the same direction. Now that's assuming that there's no other forces acting on it, when we'll get to that later. So for right now, let's just assume that there's no other forces acting on the Earth, so that the spin axis of the Earth always points in the same direction, and that is going to be towards Polaris. Okay, so now let's pretend that this is the sun. It's actually the moon, but let's pretend that this is the sun. And what we want to do is we're going to take this Earth globe and we're going to move it around the sun, and we have to do it so that the spin axis is always pointing towards the North Star. So do you see that as I'm moving it around the sun, the spin axis is always pointing in that direction? So now let's say that it is like this, so that you've got the sun is here, and here's the spin axis, and so the spin axis is pointing towards the sun over here. So what that means is that the northern hemisphere is going to be getting extra sunlight as a result of that. And now down here in the southern hemisphere, it's more curved than what it is up here, and so the sunlight is going to be more spread out underneath the globe than what it is up here at the top. So this is going to get extra sunlight up here, this is going to get not as much sunlight down here, and so that's going to be what time of year in the northern hemisphere? That's going to be summertime. Okay, and then in the southern hemisphere, it's going to be winter time. Okay, now let's take the Earth and orbit it so that it's over here now, so that the sunlight is going to be hitting this part of the globe the same amount, then it's hitting this part down here, and then that's going to represent fall. Okay, and then if I orbit it, so now the Earth is now over here, so now the spin axis, it's still pointing towards Polaris up there, but now you can see that the spin axis is closer to the sun in the southern hemisphere. So now the southern hemisphere is getting more sunlight, so it's going to be summertime in the southern hemisphere, but in the northern hemisphere it's pointing away from it, so it's going to be winter time up here. So it's always going to be opposite. If it's winter up here, it's summer down here. If it's summer up here, it's winter down here. So they have opposite seasons. Okay, now what do you suppose would happen if the Earth was tilted like this, straight up and down, and compare that to what would it be like if the Earth was tilted like this, so that the spin axis was sideways? So we'll talk about that in the next segment.